So today I will present the fourth research paper analysis. So the title of the paper that I analyzed is using natural language processing to automatically detect the self-admitted technical debt. So this paper has been accepted to 2016 IEEE Transactions on Software Engineering. So TSE defined a theoretical result and empirical studies that have potential impact on constructions, analysis, and management of software. So the scope of these transactions range from the mechanism through development of a principle to the application of those principles to specific environment. So in order to determine the venue quality, the TSE is one of the reputable venue, is listed as the one main software engineering research journal, and this paper has been published in the beginning of this year, so it has 0 citation counts. So as far as the problem statement of the work, so as per prior work, the recovery of the technical debt could be done using the source code analysis. But in this paper, they use the source code comment that has two advantages over the traditional approach of the source code analysis. First, it's more lightweight. It doesn't require the construction of the abstract syntax tree or other advanced source code representations. So, for instance, some code smell detector that also provide refactoring recommendation to resolve the detected code smell generate the computationally expensive program representation structure, such as the program dependency graphs, in order to match the structure code smell patterns and compute metrics. On the other hand, the source code comment can be easily and efficiently extracted using just regular expression. In addition to that, research in the self-admitted technical debt heavily rely on the manual inspection of the code comment. And as we all know that the manual inspection subject to reader bias and susceptible to errors. Therefore, authors found that there is a need for automatic detection of the self-admitted technical debt. So the basic idea of this paper is to present an approach that automatically identifies the design and requirements self-admitted technical debt using natural language processing. So this paper seeks to answer the following research question. So is it possible to determine if NLP technique can outperform the accuracy of the current state of the art? And what are the words that developer used when expressing the technical debt? And lastly, how much training data do we need in order to effectively detect the self-admitted technical debt? So this slide shows the overview of the approach. First, they extract the source code from the project and then extract the comments from this project using the JDeodorant tool. And then since the source code comment can be used for different purpose, the author apply the filtering to remove comments that are irrelevant or less likely to have self-admitted technical debt. And then after that, they manually classify into different type of self-admitted technical debt. And lastly, our goal for this paper is to do the classification using natural language processing. And so this table show the 10 Java open source projects that's used in the study, along with the details for each of the projects. So coming to the result for the research questions, so the answer for the research for the first research questions is the author found that they could identify the self-admitted technical debt accurately, and their approach outperform the current state of the art. So as you can see from the table, our approach outperformed the comment pattern by 2.3 times for the design depth, and outperformed the comment pattern of six times of the requirement depth. And this graph just show that how NLP approach, which is the green part, outperform the other approaches for design and requirement depth. So the result for the second research questions is showing that any words related to the sloppy code or medical source code quality are best indicator of the design depth, whereas words related to the need to complete a partially implemented requirement in the future are best indicators of the requirement depth. And the result for the last research question is that in order to reach the performance equivalent to 90%, only we need 23% of the comments that are required for both design and requirement. And for a performance equivalent to 80%, only 9 and 5% of the comments are required for design and requirement depth, respectively. So, in order to a way to improve the paper, I would suggest to consider the two approaches, the source code comment and the code smell analysis, in order to accurately detect the self-admitted technical depth and make the study applicable for different programming languages. In addition to that, provide an accurate clarification on how the maximum entropy classifier is used in the study and how feature weight is calculated. And lastly, I would suggest to build a tool that will support the software engineer in the task of identifying and managing the self-admitted technical depth. So that's all about the fourth research analysis, and thank you.